All right, guys. Are there any questions over any of the assignments so far? All right, guys. So the first one we're looking at today, 2 to the x is equal to 7. Now, what we've learned so far, because what we did yesterday was solving them, if we can get the bases to be the same, then we can set the exponents equal to each other. But unfortunately for this here, there's no way that we can write 2 to a power and get 7. Because 2 to the 7th, or 2 to the x will not be 7. There's not a number that will work for this here. So what we have to do is use logarithms. So if our 2 to the x is equal to 7, we're going to apply a log to both sides to get this to simplify down. Now for this here, especially when we only have a variable in one of the exponents, I'm going to use a specific logarithm. So I'm not going to just apply any log to both sides, but I'm going to apply log base 2 to both sides. And part of the reason for this is because the variable that we have, this x, is to the base of 2. We have 2 to the x. Now, part of our properties with logarithms, our exponential or exponent property, states that whenever we have an exponent inside a logarithm, we can move it to the front. So that tells us specifically that this here is x times log base 2 of 2. You can go on and go. So I apply log base 2 to both sides. We can move the variable in the exponent out front, giving us x times log base 2 of 2 is equal to log base 2 of 7. Any questions on any of this here? What is log base 2 of 2? What is this value? What is the value of log base 2 of 2? 1. Because whenever the base and what's inside the logarithm are the exact same, it reduces to 1. Now in the graphing calculator, we can do math log base 2 of 2 and see that this is indeed 1. So really we have x times 1 is equal to log base 2 of 7. Or really we just have x. So at this point here, I just need to figure out what the value of log base 2 of 7 is. Now there's two ways we can find it. One is using the graphing calculator, doing math. Log base 2 of 7, which is 2.807. We'll go 3 decimal places. And we get this here. Now the other way we could have solved log base 2 of 7 is our change of base formula. And the change of base formula states that log base b of x is equal to log of x over log of b. So for us here, we could have typed it in the other calculator as log of 7 divided by log of 2, which will still give us 2.807. It'll give us the exact same answer. Any questions on this here? Are you ready for the next one? 3 to the x is equal to 8. So to get the x out of the exponent, we need to apply a logarithm to both sides. What log should we apply? Log base what? 3. So I'm going to apply log base 3 to both sides because our log base 3 of 3 to the x, well, the x can move to the front, telling us that we have x times log base 3 of 3 is equal to log base 3 of 8. The log base 3 of 3 is indeed 1, so we just have x by itself is equal to Now we just need to evaluate log base 3 of 8. So we can go math, log base 3 of 8, which is 1.8927 or 1.893. And that's it. Questions on any of those here? Questions on anything we've done thus far? We ready for the next one? Seven to the 9x equals 15. So what can we do first? We're going to apply a log to both sides because we need to get that 9x out of the exponent. Now, what kind of log can we apply to both sides? Log base 7. Now, the 9x will move to the front, telling us that we have 9x. Log base 7 of 7 is equal to log base 7 of 15. Now over here, log base 7 of 7 will reduce to 1, leaving us with just 9x is equal to log base 7 of 15. Well, up to this point, after applying log base of whatever the number is to both sides, we ended up getting x by itself, the variable by itself, yes? Is the variable by itself. So what do we need to do to both sides? Divide by 9. Log base 7 of 15 divided by 9. Now at this point here, we can plug it into a calculator. Alpha y equals enter. Math. Log base 7 of 15 all over 9 is 0.155 because we'll round to the nearest third decimal place. And that's our answer. Any questions on any of this here? We like this here so far. Now with most logarithms, as we can see here, they don't give us nice numbers, because if what's inside the parentheses had been, say, 49 or some power of 7, it would work out nicely. But in most cases, it doesn't. So we really need to wait to the very end to calculate it out. We don't want to round between our first and last steps if we can avoid it. Any questions on any of this here? Let's look at this one here, and then we'll move on to the next type. So when we look at this here, 5 to the 3x plus 7 equals 113. 311, not 313. What can we do first? We can apply log what? Log base 5 to both sides. And I'll really use this especially if we only have one variable or one exponent that does have a variable. Now it'll move the 3x plus 7 to the front. And what it's telling us is that we have 3x plus 7 times the whole thing times log base 5 of 5 is equal to log base 5 of 311. And as we know already, log base 5 of 5, this whole thing is the same thing as 1. And if we multiply anything by 1, so 3x plus 7 times 1 is just 3x plus 7 is equal to log base 5 of 311. Questions on this here, how we got to this point? Now we just need to solve for x. So the first thing we can do in solving for x is subtract 7 from both sides, yes. Which will tell us that we have 3x is equal to log base 5 of 311 minus 7. And then we would divide both sides by 3, which will tell us x is equal to log base 5 of 311 minus 7 divided by 3. Now, if we want to approximate the decimal, we just have to plug this in. Alpha y equals enter. Math. Log base 5 of 311 minus 7 all over 3 is negative 1.145 if we're rounding to the third decimal place. And that's it. Questions on any of this here? Questions on anything we've done so far? We ready for the next one? I think we feel pretty comfortable with these here, yes? I don't think we need to see another example one of these because it's not any different, except this here we'd use log base 7. So I want to look at this one here next because I think we're actually almost through with the notes, or at least this part, because we'll deal with some others here in a minute. I want to look at this one here because we do have 36 and 4026. Now, in the calculator, let's see here, 6 to the 4th is that 6 to the 7th. No, 4026, like 36 squared, 36 cubed. Okay. I was trying to see if we could make a value of these be the same. So, I don't know, 2 to the 8th, or 2 to the 7th, 2 to the 6th. 64, 2 to the 5th is 32. Okay. So there's no way to do this. So what we can do is just apply log base 36 to both sides. And if we do that, the 12x minus 5 moves to the front, leaving us with what? Log base 36 of 36, yes? Well, log base 36 of 36 is just 1. And if we do know that it is indeed 1, we can just cancel it out. Now at this point here, we can add 5 to both sides, telling us that 12x is equal to log base 36 of 4026 plus 5. And last but not least, we can divide both sides by 12, telling us x is equal to log base 36 of 4026 plus 5 all over 12. And at this point here, we can plug it into the calculator and get our answer. Any questions on this here? Okay. Now, the other type of equations we can look at are these here. And the main difference between this one and the ones before is that we have E. E is going to be used for this here. And whenever we have an equation with E and X is in the exponent of E, the first main thing we want to do is get E by itself. We want to get E by itself first. So looking at this equation here, what's the first thing we can do to get E by itself? We can add 7. But we still have 4e to the negative 0.3x is equal to negative 7 plus 7 is 0. Well, 13 plus 7 is 20. Now looking at this here, is e by itself? What do we need to do? Divide both sides by 4. And if we divide both sides by 4, we get e to the negative 0.3x is equal to 5. Any questions on any of this here? Now, all the ones we've done so far, we applied a logarithm where the base and the number inside would simplify out. What log do we use that has a base e? Because we can say log base e, but the other way we write it is what? ln. Because the natural log's base is understood to be e. So if we apply the natural log to both sides, the properties of logarithms still hold true. The negative 0.3x is moved to the front, and we have it multiplied by ln of e is equal to the natural log of 5. But the natural log of e is 1, so it's really just telling us that we have negative 0.3x is equal to the natural log of 5. Questions on any of this here? Well, last but not least, x is not by itself, so we have to divide both sides by negative 0.3, negative 0.3, bless you, telling us x is equal to the natural log of 5 divided by negative 0.3. Any questions on this here? Now, the nice thing with natural logs is that if we plug this into the calculator, we can just do the natural log of 5 over negative 0.3 and get our answer. We don't have to go through and do math and find the natural log base because it's understood to be e. And if we go 3 decimal places, we get negative 5.365. And that's the final answer. Any questions on any of this here? We ready for the next one? Yes. So if we look at this next one here, 3e I'm going to rewrite it. 3 to the x minus 4 is equal to 8. You can rewrite it if you want. I'm going to rewrite it so that we can see it a little bit better than the very pixelated image on the screen. But again, we do have e to the x, so the first thing we need to do is get e by itself. So what can we do first to get e by itself? Add 4 to both sides. What next? Divide by 3. And when we divide by 3, it's telling us that e to the x is equal to 4. Now again, with any of these here, we want to get the number to the exponent, or the variables add by itself. Now all the ones we started out with, the number with the variable and the exponent was already by itself. Because the first one we had was 2 to the x equals 7. 2 to the x is already by itself. We can simplify from here. These here, it's not, so we do need to get it by itself. And now that it is by itself, what can we do to get the variable out of the exponent? We can apply the ln, the natural log, to both sides. This will move the x out front, telling us x times the natural log of e is equal to the natural log of 4. And we know the natural log of e is 1. I jokingly thought of it this way. 1. Because it does simplify out, leaving us with x is equal to the natural log of 4. And at this point here, we can just plug it into the calculator. ln of 4 is 1.6 or 1.386. And that is it. Questions on any of these here? Any questions on anything we've done so far? We ready for the next one? Do we feel pretty comfortable with these here? So we're good if we don't see another one? Okay. Now the next type, we're going to look at this here. Log base 2 of 5x minus 17 is equal to 3. Now whenever we have logarithms, kind of like exponentials, I didn't say this at the beginning, I should have, we want to get it by itself, especially with logs. We want either to have logs on either side, 1 on either side, like we had yesterday, because we had log equals log, the bases are the same, we can solve from there. If we have logs and a number not inside of a log, so here the 3, we want the number on one side, we want to get the logs on the other. Because really what we want to have is one logarithm, no matter what's inside, just one of them, is equal to everything else, equal to a number. Because once we get it set up in this fashion, what we can do is apply whatever the base is to both sides. And the reason we do this is, I'm going to write this over to the side, is our property that we had the other day, b to the log base b of x is equal to x. It's equal to what's inside. If we put it to that log to the base of b. If the base and the base of the logarithm are the same, they'll simplify out. So what that's telling us, if I put both sides to the base of 2, the 2 to the log base 2 of 5x minus 17 is going to simplify to what's inside the parentheses, which in our case here is going to be 5x minus 17 is equal to 2 to the third. Questions on this so far? Now up to this point, today specifically, whenever we applied the logarithm to both sides, we didn't get a nice number. Because log base 2 of 7 was not nice. All of these logarithms were not nice. Is 2 to the third a nice number? 2 to the third is 8. So most of these here will give us a nice number. When I say a nice number, I mean it will not give us a non-repeating, non-terminating decimal. It will not give us an irrational number. But this here, 2 to the third is 8. That is a nice number. And from here we can solve. So our next step in solving would be 2, add 17 to both sides, which will tell us that 5x is equal to 25. And last but not least, we would divide both sides by 5, telling us x is 5. Questions on any of this here? Now we could plug it back in and check to make sure, because we could say log base 2 of 5 times 5 minus 17 is equal to 3. Well, we could plug that into the graphing calculator. Say math log base 2 of 5 times 5 minus 17, and we would get 3. So that is the correct answer. Any questions on this here before we look at the next one? Log base 3 of 10x minus 9 is equal to 4. So what can we do first? We can put both sides to the base of 3. Because 3 to the log base 3 will cancel, leaving us with 10x minus 9 is equal to 3 to the 4th, yes? Is 3 to the 4th a nice number? Yes, it is 81. Three to the 4th, 81. What can we do next? Add 9. Telling us that 10x is equal to 90. And last but not least, we would divide by 10. Hopefully we know what 90 divided by 10 is. And that's it. Now we can plug it back in and check and make sure this will work. The main thing, especially when we're checking, is that whatever's inside the logarithm, well, that it does actually work. Plugging 9 back in to the log will indeed give us 4, but also that what's inside the logarithm is not 0 or negative. We cannot have 0 or negative inside of a logarithm. Questions on any of this here? Do we need to see another example of one of these? As if we did go through, we'd put 2, 2. These would cancel, telling us x minus 6 is equal to 2 to the 5th. Then we can add 6 to both sides, telling us x is equal to 2 to the 5th plus 6. 2, 4, 8, 16, 32. So x should be 38, I believe. But that's it. Questions on any of this here? Any questions on anything we've done so far? And that's it.